and say that, yeah, welcome everybody to the 5th Sasensei International Dojo. We're fortunate to have Stu on the line, who's going to tell us all about the use of RSUBMIT. So Stu, over to you.
Awesome. Thank you, Alan. Everybody, welcome. This is parallel processing using RSUBMIT. My name is Stu Stokowski, and I'm an analytic consultant in SAS's U.S. Professional Services Division, which basically means I'm a SAS programmer and analyst just like all of you guys. We get customers who want to do some analyses. We go in and we build processes in SAS and other languages as well, and then deliver it out to them in whatever results that they are looking for. I primarily focus on forecasting and visualization, and I love to hear from you guys. I love to these types of things are some of my favorite things to do, to talk about some of the weird solutions and things that we've come up with and explain it to you guys in a way that hopefully makes sense. And I would love to hear your feedback, and I would love to hear from you. So feel free to reach out to me at the email address there, or if that last name is difficult to remember, just go ahead and reach out to me at LinkedIn.
Stu,
LinkedIn. Yes.
Maybe it's me, but I don't see your screen.
You don't see my screen. Uh-oh.
Can anyone else see the screen?
Nope.
Okay.
Stu, your last name sounds like you have Polish roots. That's true?
That is correct. Yep, I've got a Polish background.
Perfect. The best SAS are from Poland.
There's evidence of that. Yeah.
All right. Well, how about this? Are you able to see this now?
I don't.
Uh-oh.
Let me check.
No.
I'm making you host, Stu.
Okay, great. My apologies for this.
You're now host.
Okay. Let's get this working now. How about now?
That's working. Yeah.
Yeah.
Excellent. All right. All right. Excellent. Got that now resolved. So anyway, you are more than happy to reach out to me at any of those places, and I would love to hear from you and talk with you. And just if you want to come up with some solutions to any sort of weird SAS issues you're running into, I'd love to do that as well. All right. Today we're going to talk about what RSUBMIT actually is and go through a really basic example of how to use it to run some programs in parallel. Then we're going to talk about how to parallelize one data set, and then talk a little bit about how to parallelize, or how Viya does parallel processing natively, particularly with the data step. We'll just briefly touch on that because that can be a whole conversation in and of itself. Let's get started. When we normally write SAS programs, we're normally writing them serially. You write something, you write a step, you wait for that to complete, you write another step, and you wait for that to complete. A lot of the times in our programs, we've got things that we don't necessarily need to run in serial. You can in fact split some of these things out so that something runs in parallel with another process. And in SAS, you can really easily do this with this thing called RSUBMIT, which effectively creates two independent SAS sessions that go out. These independent SAS sessions are almost equivalent to opening up a new SAS session on your computer and running stuff in it. They've got their own work directories, they've got their own macro variables, they're totally independent of each other. You split your data out, or your processes out, you run them independently, you wait for them to complete, and then you bring it all back together at the end and continue on. That's the basics of RSUBMIT. Multiple parallel SAS sessions all running. It's kind of like multi-threading, but it is possible, in fact, to have multi-threaded stuff going on within each RSUBMIT session, technically. Why you want to actually do this? Well, it's going to speed up your runtime, and it's going to make a lot more effective use of your resources. We have computers nowadays that have an insane amount of cores, and cores are just the new computing commodity. It used to be all about gigahertz back in the day, and now it's about how many cores you got, how much memory do you have. And most SAS programs that people write tend to be single-threaded because it's really easy to write programs that way. Sometimes you've got huge data sets or huge analyses that we need to run, and we can use our cores more effectively and our memory more effectively by splitting them out. And in the end, you're going to get something that runs significantly faster. And we've got a couple of case studies that I'll talk to you about. The biggest downside of all of this is that it's going to be harder to debug. Writing programs serially is the easiest way to program. It's easy to work with. And it is the way that I would recommend you do things unless you need to get something done really quickly. Always start off serially before you get into parallel, because you don't want to be debugging stuff when you've split it all out and trying to figure out, is something wrong with my RSUBMIT statement or is something wrong with the data set? So let's talk about how you can actually go ahead and do some basic RSUBMIT syntax. And this is what it looks like. It's surprisingly not a lot of code to do, and they make it pretty simple for you. The options above are mostly just options and things to make things a little more simple for you to work with. But in the end, this is really all you're doing. You're taking some options, you're turning them on, and then each RSUBMIT block are 2 pieces of parallel code that are going to run, and then you just wait for it all at the end. And that's all you're doing. Let's break down each one of these individually. This auto sign-on equals yes. This is an option that you want to have. It helps make things way easier for you to do. Basically what it means is whenever you run your RSUBMIT statement, just go ahead and sign on with your current credentials. Don't worry about individually typing in your password, putting that in open code. Let SAS handle all of that stuff for you. No connect wait says to run everything in parallel. RSUBMIT was also designed to run things remotely on remote SAS servers. And in those cases, you might want to run something remotely and then have it wait and run things almost serially in a remote fashion. So by default, it's going to run things serially. If you add the no connect wait option, it's going to ensure that all RSUBMIT sessions go out and run simultaneously at the same time. No connect persist is really nice. It just means that once your RSUBMIT session is done doing what it's doing, it signs off and you can free up those resources again. You don't need to do this. You can manually sign off each RSUBMIT session, and this might be helpful if you want to call multiple RSUBMIT sessions multiple times and you don't want to have it sign on again. That's totally optional. If you do, you want to make sure you use the sign off statement at the end to sign off those RSUBMIT sessions. And finally here, with the last option, this one's kind of important. This is basically running telling it what SAS command to use to kick off those new sessions. So like I said before, it's like starting a new SAS session in your computer. And this exclamation point SAS CMD option just means use the exact same one that you used to start this session so that everything is pretty much in sync as far as all those options that you use. You can also specify other options. I like to turn off the notes and the news because when you run a lot of RSUBMIT sessions, you're going to fill up your log pretty quick, and that can help. You can always turn them back on if you need to do debugging. Here is where all the work gets done. Your RSUBMIT blocks are like writing code somewhere else. Basically, what these 2 things are doing is it's creating 2 new SAS sessions, and you're inheriting the library from your main SAS session. In this case, it's called mylib. This will make it easier because you now don't need to reassign any new libraries, and when you run your code, you can output all of your data into a single common library. That remote equals worker1 will identify the specific worker that you're using. It's just a name that we give it, and we're just going to call it worker1 or worker2. Just keeps them easy to identify, and that's the name of the session going out there. The most important thing to note is that when you run open code like %let, it's going to be executed in your main session. Working with macros inside of RSUBMIT can get a little bit tricky. Knowing where things are going to execute within RSUBMIT versus your main session gets weird with macros because macros will compile before your program actually does. There's a really great website or a really great explanation on SAS's website that goes through examples of how to run specific macros within RSUBMIT sessions. for this purposes of this today, we're not really going to run anything that is going to affect it in this way. For the most part, just assume that any SAS code that you write within RSUBMIT is going to run within that RSUBMIT session. And then finally, at the end, you just wait for everything to complete. This just says, don't do anything any further in my main session until all of my workers are complete doing whatever I want them to do. You can also add timeouts, and you can also tell them to wait individually, but I just like to do wait for all because, well, I'm lazy and I don't want to type out each one of those. So that's it. That's how you just do your basic RSUBMIT parallel processing. The thing is, though, you're probably going to want to use your work directory, and you're going to try to use your work directory, but SAS will get fussy and say that you're not allowed to reassign it because the work directory is a special name that each individual RSUBMIT session is going to have. Well, sometimes SAS doesn't know what it can actually do, and you could get around that. Just create a new library that points to your existing work directory and tell it to inherit that instead. And ta-da, now you can use your work directory. It's just under a different name. That's the trick that I use because I don't want to go and find something that's on a separate partition or has enough space. And usually your work partition is specially set out to do these types of things. So you just create a new library reference to the work directory that works just fine. We talked about how to parallelize multiple sessions, but what if we wanted to parallelize one single data set? Splitting it up into multiple chunks and analyzing those chunks individually and then giving us the results back. We could do that. And the strategy is very similar to what we did before, except the difference is we just need to figure out how do we split the data evenly into these unique rows. So all we're going to do is figure out how to split those up, run our code on those data splits with each parallel worker, wait for them all to complete, and then combine the results in the end. And doing this can give you some significant time savings. So for the first step, we just need to figure out what our split points are. And this is the hardest thing that you'll do out of this whole thing. These two things that are going on here. The first thing, this is a little macro trick that you can use to get the total number of rows in a data set. And then you'll just store it in a macro variable we'll call n. Within this macro loop that we're building, we want to reference this to figure out how much we need to split out to each worker. Once we then jump into our loop to do this thing for a number of workers, we figure out what is the first and last observation that worker needs to analyze. So it gets its own little set of unique rows. Now, this looks kind of weird in this formula, but I promise you these formulas do in fact split up things evenly for both even and odd numbers of rows. And I'd be more than happy to show you the math behind that and how it works in the question section if you'd like to. But for now, don't worry. Just promise you that this number will split out, and I've got all this on GitHub as well so that you can just copy and paste this and you don't need to worry about that. Now the hard part's done. We just need to tell each worker what they're going to work on. Before I said that each worker session has its own set of macro variables, and it's like its own new SAS session. Before we start using macro variables in our main session, we've got to tell our worker sessions what those macro variables are. We can use that with %syslput. This is a special macro statement that all it does is this is taking every user-generated macro variable and it's going to send it over to our remote worker when it signs on, so that when that worker signs on, it has the same macro variables for first obs, and W, which identifies the worker, so that they now know what observations and what number that they are. Once we do that, now we just tell it to load some data set and only go between a certain number of observations. You'll notice that there's that control-lev equals rec option there. That just says don't lock the data set so nobody else can see it. Do it at the row level. And this prevents everything else from locking each other and then giving you warnings and errors. Since everything is already being split up into unique rows, you don't need to worry about any warnings that some procs might give you saying that it's supposed to run on the whole data set and you'll get unexpected results. It's okay because you already know that you have unique observations. Alternatively, you can create a subset of the data for the primary data set and run it that way as well. So we got through all that. Now we just wait. And that's pretty much it. Nothing else to say here. And then we put it all together. And you could do that with whatever your favorite flavor of combining stuff is. You could do it with proc append, you could do it with the data step. I like to name all of my temporary data sets with an underscore. And in this case, it's underscore cars, underscore, and then all the worker numbers. And then I could just do a simple set statement and put them all back together. Once you're done, you can use proc dataset to delete all those underscore temporary data sets once it's completed. That's a good idea to do because you will have effectively 2 copies of your output once you do this. So you want to prevent your work directory from filling up too much. When you put everything together, this is what it looks like. It's not a whole lot of code to do it. It's maybe 15, 20 lines or so. And I've got this on GitHub, so you can just copy and paste it and use it as you like. But that's all there is to it, and that allows you to split your data up and analyze it in individual rows. This isn't thread safe though. If you've got by groups and other things like that, or row dependent operations, this is going to be a little harder to do. You'll need to be able to split it out by your by groups and adjust for your row dependent operations. But I can at least tell you a couple of case studies where this is really useful for, other than just doing really intense data step work. So recently we had a customer who wanted to work with some geographic data. And we had a 6-core, 43 gig, 500 gig workspace server. And they needed to analyze something with 7 million rows and 28 columns in it. We needed to do 2 things to it. First, we needed to geocode it. If you've ever done street level geocoding, it's a memory intensive, IO intensive, CPU intensive process that really runs it through a lot of different processes because it's trying to do all this matching, and it can take quite a while. With 1 worker, this took 2 hours and 19 minutes. We split it out to 6 workers, 25 minutes, way faster. After we did that, we needed to do something called proc G inside. Proc G inside is another pretty intensive operation, depending upon your data, that takes a look at polygons and it finds out if points lie inside or outside the polygon. We had 2 million polygons we needed to match all of these 7 million rows to. With 1 worker, it took about 18 minutes. 6 workers, it took 3 minutes. So this whole thing from start to finish using 6 workers took 28 minutes as opposed to well over 2.5 hours for just pretty quickly. That ran really fast and was really nice for us to do, and also allowed us to do debugging, allow us to rerun this multiple times in case we needed to check on different things. Even with running it on 6 workers with this relatively basic server that we had to work with, I was surprised that SAS ran just fine, even with other users on the system. The OS did a really good job of managing memory and managing CPU usage overall, so I was pretty impressed with that. Now, I'm not saying you should go out and use every single core that you have with your SAS system that you're using if you have a lot of people using it, because you might have an angry admin coming and asking you why the CPU is pegged at 100% for every core and people are complaining that it's slow. Try testing it out first a little bit before you jump into using all of the cores as possible. But we wanted to see, man, like, what can this handle? And it was able to handle it pretty well. Well, that's in the SAS 9 world. How about the Viya world? In Viya, everything is all about in-memory processing in parallel. We'll briefly talk about this a little bit on how this works and what goes on in the background there. In Viya, everything is done in something called CAS, or Cloud Analytics Services. By default, all of your rows are distributed among workers if you have multiple workers. If you don't, it'll all still be on one system. However, your data step is natively multi-threaded. You don't need to change anything in what you do with your normal data step, except make sure that your data is in CAS. If your data is loaded in CAS, in a CAS library, your data step will automatically take advantage of as many threads as possible to process it in the exact same way that we did previously. In addition, CAS actions are designed in parallel. Whenever you run stuff in CAS, it is most likely going to be doing it in parallel, depending upon the CAS action. I would say most CAS actions are designed this way as far as the ones that I've run into. So parallel processing is just a native part of this on a single data step. If you wanted to run parallel CAS sessions, you can actually still do that. You could do it with RSUBMIT still, but in CAS language, which is a new language that's been coming out, there's this nice little function called create parallel session. And that just automatically runs a new CAS session for you in parallel. It's very similar to RSUBMIT, but very specific to CAS. The concepts are still the same. You still run something in parallel, wait for it to complete, and combine your results after. So those things that we just learned can still apply in Viya the same way. When it comes to the multi-threaded data step, though, all the threads are independent of each other. And every data step is like a bunch of tiny little data steps all running in a bunch of different threads. It splits it out amongst all the workers, and then it splits it out amongst all the threads on the machine. If you have row-dependent operations, those things will need to be looked at pretty carefully because it doesn't have thread safety for using anything outside of a by group. The nice thing with CAS is that by group operations are thread safe. So if you do something by a certain variable, first dot and last dot, for example, will work exactly as you expect. But if you wanted to do it without by groups, it may not behave as you expect because it's going to split it up randomly in a fashion amongst all the workers that you won't know. When you use by groups in CAS, it will first look at your first by group, and it will find out, okay, how many, what is the cardinality of that? How many groups do I have? And then it's going to take each group and give it to a worker. Then within each worker, it's going to split that out into individual threads. This means that your first by group is very important. You want to use the highest cardinality by group that you have in CAS because that means it's going to make use of all the workers. Just a little thing to think about. If you need to do something by a certain by group and the by group order doesn't matter, make sure that your highest cardinality by group is first. And that will make sure that all of your workers are being taken advantage of instead of just a few. We've reached the end, and those are some of the things that I've been using to help make my code run a little bit faster and a little bit more efficient, especially at times when somebody needs something pretty quickly and it might not be necessarily a ultra high priority, but it's something that still needs to get done. And if it's on a big data set, running RSUBMIT can really, really speed up that processing so that you could get your results out much faster. Plus, it's also kind of fun to do. I love taking things that run kind of slow and figure out how to make them run fast. That, of course, comes at the cost of complexity. So don't make it too complex, but thankfully RSUBMIT make things pretty easy to deal with for the most part. Everything that we talked about here can be found at GitHub. And I'll link the GitHub to you guys so that you can download these things. I've got that parallel macro that's in there that allows you to run some data in parallel. And I've also got just your basic RSUBMIT code that is all there too. So you can download it, play with it, modify it, do whatever you want with it. Yeah, that's pretty much it. Does anybody have any questions or anything?
Hi, Stu. This is Louise Haddon. And this is really great because I'm working on a client system for the state of Maryland. And I'm dealing with billions of claims. And I think this is really going to help me out some of my runs are taking, 6 hours.
Yeah.
But I also work on another client system, and they have grid computing. And I'm wondering how this works with grid computing, or is, because it's kind of transparent to us. We have to use Enterprise Guide, and I think it's automatically getting submitted to the grid system. And I'm just curious as to whether this would interfere with it, or whether this would be faster than it, or any other insights on that.
Yeah, that's a great question. Yeah, because I haven't been lucky enough to use a grid system yet. But from what I understand from grid is designed to basically do that, where it's going to split things out for you. Is that right? Where it kind of figures it out?
I think that's true. And I was just curious, whether you'd ever encountered it or not. I think a lot of people don't have grid because they're a little higher up the food chain.
That's a really good question. If grid is going to split it out automatically and you run RSUBMITs within that, in theory, I guess what it would do is then take those and almost kind of do what Viya does, I would guess, where Viya will will take a chunk of data, send it to a worker, and then split those chunks up into individual threads. I would imagine if you did that with the second RSUBMIT example, that's probably what it would do. I would guess. It's a really great question, though. I would give it a try. see what the results are. Yeah,
All right.
yeah.
All right. I'm just curious. So thank you.
Yeah.
Thank you. Great presentation.
Hi, Stu. Bart's here once again.
Yes.
Just one comment, because the one thing which we have to add here, that you need SAS Connect to be installed on your system to use RSUBMIT, right? So basically, without SAS Connect component, you won't be able to use RSUBMIT.
That's right.
On your system, and in case when you don't have SAS Connect, you can always use the systask to develop more or less the same features for running multi parallel processing. And few years ago, I had the presentation about it and some materials on the web, how to get exactly the same results as you have with the RSUBMIT with just a systask, because on our system we didn't have any additional components except for the base SAS and some stats, I think components, and we had to figure out the parallel processing ourselves. But fortunately, we had the administrator who turned on X command. So we were able to use systask, which also has all those nice features, which allows you to check whether all threads finish their job, and you can wait for all of them and then combine results. Just like one more final remark, when we were testing the parallel processing with the RSUBMIT, there were like two interesting observations. Once, when we ran one code which was usually one threaded, and it was working for 100 minutes. When we moved it to 16 threads with this systask macro we wrote, we gained like 97% of time improvement. So basically, we jumped from 100 minutes to 3 minutes.
Wow.
And the other situation was because this macro was also functioning on our local laptops, because we also were using local laptops for some calculations. And the funny thing was that the best results we got when we were using five independent processes on 4 core machines. The overhead on the disk drive was that the 5 processes were working faster than 4 on a 4-core computer.
Oh, that's really interesting. That's really cool. Yeah, I would love to. Yeah, if you could like link that presentation, that'd be great because, yeah, that is the other way that you do it, and I've seen other people do that as well with systask, and yeah, there's multiple ways to do it, and that's great. That's really cool.
Yeah,
Thank you.
I've put it on the network in the form of like SAS code with like a lot of tutorialish comments. So basically, you can go through the code reading the comments, and you will get full instruction how to use it, right? So it's available on the network, so I can share.
Awesome. Thank you.
We've had one question in the chat, and just a reminder to anyone who'd like to ask a question, you can use the chat. So about the video will be on YouTube. And about the slides, if Stu, are you able to share the slides with us?
Absolutely.
Great. So any more questions from anyone? Nothing coming through. So I'll just take this chance to say thank you for a very professional, very good, very informative presentation.
Thank you so much. I really appreciate it.
Yeah, that was really good.
Really good one. Really good one.